What is the average rate of change of the function f of x equals 2x squared plus 3 between intervals 1 and 3? All right, so average rate of change is the formula f of b minus f of a over b minus a. I will call you A and I will call you B. So if I wanted to find f of b, because I already have a and b, that's easy. If I wanted to find f of a, we'll go with alphabetical first. That would be me finding f of 1. So I replace f of x. Every x is going to be replaced with 1. So 2 times 1 squared plus 3. 2 times 1 squared is 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 is 5. F of b is going to have me replace every b with every x with a 3. So that's going to be f of 3 equals 2 times 3 squared plus 3. PEMDAS says 3 squared first. 2 times 3 squared is 2 times 9 plus 3. 2 times 9 is 18. And 18 plus 3 is 21. 9 plus 10. So let's plug all that stuff in. All right, f of b was 21 minus f of a, which is 5, all over b, which was 3, minus a, which is 1. 21 minus 5 is 16. 3 minus 1 is 2. And 16 over 2 is 8. So there you have it. The average rate of change between 1 and 3 of this quadratic right there is going to be 8. You're welcome. Using the interval x and x plus h, find the expression that represents the slope of the secant line. All right, so the slope of the secant line is just fancy talk for slope. So let's use the slope formula. The slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now in pre-calculus, and AP pre-calculus, you might view this as this differently, and this is how I'm going to view it. F of b minus f of a over b minus a. So yeah, I am treating this like the average rate of change. You would be my a, you would be my b. So if I wanted to find f of a would be me replacing every x with x, so nothing changes. But this would have me replace for f of b every x with x plus h, like so. So now I come back up here and say instead of f of b, let's plug in square root of x plus h, minus, instead of f of a, let's plug in the square root of x, all over b, which is x plus h, minus a, which is x. And if you're taking a look at this and saying, those parentheses aren't necessary, you're right. Let's get rid of them. And the only thing that really happens that we're going to care about is the fact that the x's in the denominator are going to cross out. So when all is said and done, we get the square root of x plus h minus the square root of x all over h. And that's how you do it. Using the graph, what is the average rate of change of g of t over the interval 0 to 5 days? All right, so I'm given the graph. Average rate of change is just fancy talk for slope. So you're talking about the rise over run, the change in y over the change in x. So what I do is I say, all right, well, from 0 to 5 is just that little chunk right there. I'm going to find my rise, which is up 1, 2, 3. The y values or the g of t values go up by 1 every time, and I run 5. So 3 over 5. Now the weirdness of this problem comes from the wording. My y values, my g of t values are actually at rate. So my 3 is going to represent centimeters per day, and my x values are days. So it's not 3/5 centimeters per day, it's 3/5 centimeters per day. But the fact that it's 3/5 is the dead giveaway. Yeah, that's it. That's how I do that problem. Pretty simple. Find the instantaneous rate of change of the function f of x equals x squared plus 3x at the point x equals 2. This is the formula for the instantaneous rate of change. You take the limit as h approaches 0 of f of x plus h minus f of x all over h. So what I need to do is I need to go over here and find out what f of x plus h is, and then what f of x is, which I already know. So let me write that out. F of x plus h has me taking f of x and replacing every x with parentheses x plus h. So x plus h squared plus 3 times x plus h. All right. X plus h squared is a perfect square trinomial. So you're thinking FOIL thoughts. X times x is x squared. X times h and x times h is 2xh. And then h squared is h squared. Here you distribute the 3, so plus 3x plus 3h. And that's what f of x plus h is. You now also have regular old f of x, which I'm just going to rewrite out for funsies, x squared plus 3x. Now that I have these two guys, I can go back to the formula and plug stuff in. So the limit as h approaches 0 of f of x plus h is going to be what I have here in blue, x squared plus 2xh plus h squared plus 3x plus 3h minus f of x, so minus parentheses x squared plus 3x. And that's all going to be over h. Now, the scary part so far is the fact that I have the limit as h approaches 0 and h in the denominator, and if I were to plug in 0, I would get, undefined. That's no good. So what I need to do is I need to hope that some magic happens, and magic will happen. If I were to distribute the negative, I now get x squared plus 2xh plus h squared plus 3x plus 3h, so nothing's happened. Distribute the negative, minus x squared minus 3x all over h. Stuff will disappear. Okay, you disappear, and you disappear. And that leaves me with the limit as h approaches 0 of 2xh plus h squared plus 3h all over h. Notice that everything has an h attached. So pull the h out on top. So the limit as h approaches 0 of h 2x plus h plus 3, don't anything else, that was a close one, all over h, the h is crossed out. Now things are great. Okay, I have the limit as h approaches 0 of 2x plus h plus 3. So when I plug in that h, or 0 for h, u will go away. And that leaves me with 2x plus 3. However, I'm not done. At the beginning of the problem, we cared about when x was equal to. So I'm going to take 2, substitute x with 2 plus 3. That's going to get me 4 plus 3. And after all is said and done, I get a big fat 7. So very hectic problem, but we did it. All right, you ready for a killer? Because this is going to be a rough one. What is the instantaneous rate of change of the function f of x equals the square root of x plus x squared at x equals 4? The formula for the instantaneous rate of change is the limit as h approaches 0 of f of x plus h minus f of x all over h. So what I need to do is I need to come over here and find out what f of x plus h is. So that involves me taking f of x and replacing every square root, or rather every x with x plus h. And so yeah, we do have a square root, that's where my mind went. And so we get the square root of x plus h, not much I can do there, plus x squared, which is going to be x plus h squared. Now again, not much I can do there, but what I can do with the second one is I can say that you are a perfect square trinomial, and you simplify out to x squared plus 2xh plus h squared. Okay? FOIL it out, baby. Now the other guy, stuff you already know, f of x, we already know is root x plus x squared, nothing wacky happens. Now we take both of these guys and we replace both of those guys with these guys. So I have the limit as h approaches 0 of f of x plus h, which is going to be gross square root of x plus h plus x squared plus 2xh plus h squared, right? And then I'm going to subtract all of root x plus x squared. All of this is over h. Now the issue is when I have the limit as h approaches 0 and I only have h in the denominator, plugging in 0 is a no-go. So I'm hoping magical things happen, I'm hoping things disappear, and all that good stuff. First I have to distribute that negative. So I have the limit as h approaches 0 of the square root of x plus h plus x squared plus 2xh plus h squared minus root x minus x squared all over h. Now nothing special has happened yet except for the fact that u and u will disappear. So that leaves me with the limit as h approaches 0 of the square root of x plus h plus 2xh plus h squared minus root x all over h. Again, I can't plug in h. Okay, I can't plug in 0 for h because that'll make, the whole thing undefined. That's no good. But what I do notice is that u and u have an h attached. So what I can do is I can kind of move you guys to the side. So I will say the limit as h approaches 0, I can keep you two grouped together, and I'm going to do so with a little bit of space, and you'll see why. X plus h minus root x all over h. And I'm going to move you to the side and eliminate all of these h's. In fact, let me just show that step. There's no need for me to rush things. So 2, let me factor out an h. So h, 2x plus h all over h crosses out. And what I'm going to do while I'm over here is, the h on the bottom is still very problematic. What I'm going to do is I'm going to multiply the top and the bottom here by the conjugate of that guy, not friendly at all, x plus h in the root plus root x all over x plus h plus root x. Okay, so one step at a time. What that does for me here after I FOIL this out is I get root x plus h plus root x plus h, giving me x plus h, minus grossness plus the same grossness, so these guys will cancel out in the middle, and then minus x. And that's going to all be over h times the square root of x plus h plus the square root of x, right? And then this just becomes plus 2x plus h. Now all of this is still being taken with the limit as h approaches 0. Okay? So let me write that out, the limit as h approaches 0. You cancel out. Now all of a sudden I have h alone over h times stuff, and the h's cancel out. So I am left with the limit as h approaches 0 of 1, because again the x is canceled out, gone, and that left me with an h over h times stuff, so 1 over the square root of x plus h plus the square root of x plus 2x plus h. Now I can plug in my 0 and feel pretty good. Okay? So if I plug in my 0 for h, u will go away, and u will go away. And that leaves me with 1 over root x plus root x is 2 root x, and then plus 2x. Still not done yet, because x is 4. So now I have to replace x with 4. So that's 1 over 2 root 4 plus 2 times 4. Okay, in the limited space that I have, 1 over 2 root 4 is 1 over 2 times 2, which is 1/4, plus 2 times 4 is 8. So when all is said and done, we get 8 1/4. Tricky, 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 gross, tricky, gross. but that's how you do it. Oh, things are getting serious. Find the derivative of f of x equals 2x squared plus 3x using the definition of the derivative. Well, if I give you f of x, then we would call the derivative f prime of x. But what is the definition of the derivative? Well, it's the same thing as instantaneous rate of change, of course. The limit as h approaches 0 of f of x plus h, like that, minus f of x over h. So what we need to do is we need to find out what f of x plus h is, right? We have f of x, plug stuff in, hope things disappear, and wish for the best. F of x plus h means I'm going to take f of x and replace every x with x plus h. So u become 2 times parentheses x plus h, close it, square it, plus 3 times x plus h. Okay? Now, this is a perfect square trinomial, so the 2 remains out there for now. X plus h squared becomes x squared plus 2xh plus h squared, right? Distribute. So you become 3x plus 3h. And then when I distribute the 2 to all of that, I get 2x squared plus 4xh plus 2h squared, and then 3x and 3h come along for the ride. We already know what f of x is, so I'm not going to bother writing it down. So what I'm going to do is I'm going to rewrite this guy out, okay? The limit as h approaches 0 of f of x plus h, so I'm going to write that in blue. That became 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus f of x, which I underlined in purple, so minus 2x squared plus 3x, close that, all over h, like that. Okay, let's distribute that guy. So limit as h approaches 0, nothing in blue changes, nothing at all. I'm just rewriting it out like that, like that. Distribute the negative, minus 2x squared minus 3x. And when you have polynomials like we have here, you're hoping for stuff to disappear, which is going to happen now. 2x squared, adios. 3x, adios to you. And you're left with the limit as h approaches 0 of 4xh plus 2h squared plus 3h over h. Now notice all of these guys have h's, which means I can factor out an h. When you're dealing with polynomials like what we have up here, expect that to happen every single time when we have polynomials. Not every single problem, but every single time when I have polynomials. If I have an h, bring it out. 4x plus 2h plus 3, close it, all over h. See, the initial problem, by the way, is like when I got to this point after I plugged stuff in, if you're like, why don't we just plug in 0 for h? Well, you get 0 on the bottom, that's no good. But now, h crosses out. And we are left with the limit as h approaches infinity of 4x plus 2h plus 3. So all I have to do here is replace h with 0, and I get 4x plus nothing plus 3. So after all of that, f prime of x equals 4x plus 3, which is b, baby. Wasn't that fun? Find the derivative of f of x equals 1 over x using the definition of the derivative. Well, if I have f of x, that means I'm trying to find f prime of x. Now, what's the definition of the derivative? Well, that's the limit as h approaches 0 of f of x plus h minus f of x all over h. So what I have to do is I know what f of x is. Okay, there you are, your f of x. I need to find out what f of x plus h is. And really all I have to do here is substitute x with x plus h, and I get 1 over x plus h. So that's not so bad. So let's continue the problem and see what happens. And I know I'm going to have radicals or rationals or whatever they're called, and no one likes those, but nah, I'll be all right. I'll just give myself plenty of space. F of x plus h was 1 over x plus h minus f of x was 1 over x, giving myself plenty of space, all over h. Here's the issue. Can't plug in 0 for h because I get 0 on the bottom. That's no good. So what I'm going to want to do first is I'm going to want to combine these fractions up here in the numerator. That's why I left all that space there. And the way you're going to do that is you're going to multiply this guy by x over x and this guy by x plus h over x plus h. And that way I'll have on the top x times x plus h, like so. You become x, you get distributed, but it's a minus sign. Oh, be careful. So it's minus x minus h, that was a close one, all over h. So I'm still dealing with the limit as h approaches 0 of u2 cancel out, negative h over, let's distribute that out, x squared plus xh all over h. Again, h on the bottom is an issue. So why don't I multiply the top and the bottom by its reciprocal, 1 over h, 1 over h. That way the h and the 1 over h on the bottom cancel out. And lo and behold, looky what happens. That h and that h also cancel out. So that leaves me with the limit as h approaches 0. Negative times 1 is negative 1, all over x squared plus xh. Now I'm okay to plug in 0. And if I plug in 0, I end up with negative 1 over x squared plus x times 0, which makes u go away. So negative 1 over x squared is going to be my derivative. So let me write it out. F prime of x equals, let me pull that 1 completely out, negative 1 over x squared, which in this case is going to be a. Crazy fun. Let f prime equal the limit as h approaches 0 of x plus h squared minus x squared over h. For what value of x does f of x equal 4? Well, I give you the derivative. And by definition, the derivative is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. This problem wants me to find out when f of x is 4. But I'm not given f of x. I'm given f prime of x. Oh, but wait a minute. If f prime of x is f of x plus h minus f of x, that means this guy right here, f of x, is the same as x squared. So the original f of x must have been x squared in order to get to this point that we have here, which also makes sense because f of x plus h would just be x plus h squared. So, all right, that makes sense. Well, f of x is 4. So if f of x is 4, I can just replace f of x with 4 and say 4 equals x squared. In order to get x all by itself, I positive negative square root this guy. That crosses out. And x is going to equal plus or minus the square root of 4, which is 2. Okay. Now, in this case, it only wants me to probably do one of them. It's only giving me the one option, which is 2. But technically, there is 2 answers here. So, I mean, that's kind of exciting, I guess. But, yeah, that's how you do it. Kind of a weird problem. Working backwards on that one. For function f, we are given f of 5 equals negative 8 and f prime of 5 equals negative 6. Identify the y-intercept of the line tangent to f at x equals 5. So I'm just going to draw some like random graph, all right? Looking at what we have here, the derivative gives you slope at a specific point. It's a slope of the tangent line at a point. So if I were to call you 5, all right, if this was 5, the slope at 5 would be negative 6. Now, granted, my picture is not super accurate, but you get the right idea. Now, what we also know is that at this moment right here, okay, the slope is negative 6, but the point 5 also has a y-coordinate of negative 8. So we have a slope of negative 6. And also this right here is telling us that we have a point of 5, negative 8. My job is to identify the y-intercept of the line tangent to that. So what I'm going to do is I'm going to build a slope-intercept form equation for the slope of the tangent line, and from there I'll be able to identify the y-intercept. So if I have y equals mx plus b, that's slope-intercept form. I already know that the slope of the tangent line is negative 6. So what I have so far is y equals negative 6x plus b. I also know that I'm given the point 5, negative 8. So if I call you x and I call you y, I could substitute for y, negative 8, and I could substitute for x, 5, and do a little bit of math. So plus b is going to give me my y-intercept. So this is negative 8 equals negative 30 plus b, add 30, and b is going to be the Taylor Swift special, 22. So just for funsies, the graph, or the equation rather, that I would get would be y equals negative 6x plus 22. In my case, the y-intercept of the line tangent to f at x equals 5, the y-intercept is going to be that number 22. Okay? That's how you do it. Determine the derivative of f of x equals root x plus 2x at x equals 4 using the definition of the derivative. All right. Well, first off, we'll call this f prime of x, okay? And the definition of the derivative says that if you have the limit as h approaches 0, you're going to take that limit of f of some x plus h minus f of x all over h. So what we really need to do is we need to find out what f of x plus h is, right? And we do that by replacing every x with x plus h. So you become the square root of x plus h, like that, plus 2x plus h in parentheses. And then what we can quick do here is we could just quick distribute that 2, bada bing, bada bang, and then we get plus 2x plus 2h, like so. All right. Once we do that, we now have enough information to plug stuff in and do a little bit of math and see what happens. We know what f of x is. It's u. Okay, we just found f of x plus h. It's there in red. So let's take the limit as h approaches 0 of root x plus h plus 2x plus 2h minus parentheses root x plus 2h all over h. Now the issue is we don't want to plug in 0 for h because then we get something that's undefined. You can't do it yet. So we need to see if we can work some magic. First off, we can distribute that negative right there. And we get the limit as h approaches 0 of nothing changes yet, root x plus h plus 2x plus 2h, so nothing has changed quite yet. But then we can do minus root x minus 2x, and that's going to all be over h. So usually when this happens, we expect things to disappear, and that's exactly what's going to happen. So the 2x and the 2x disappear. So we have the limit as h approaches 0 of the square root of x plus h plus 2h minus root x. It's supposed to say minus root x all over h. Now what I'm going to do is I'm going to group the radicals together. I'm going to group the roots together, and I'm going to split this off to the side and simplify it a little bit. So I'm going to keep this as the limit as h approaches 0 of the square root of x plus h minus root x plus 2h all over h. Now watch what I do. Notice how I split these guys up. I can now do that, and that leaves me with the limit as h approaches 0 of root x plus h minus root x all over h. Now I'm going to leave some space here on purpose. You'll see why. You just become plus 2 all as well. Now the reason why I'm leaving space here is I still can't plug in 0. Nothing great happens. But what I can do is I'm going to multiply the numerator and the denominator by the conjugate of this guy to have difference of squares thoughts. Okay, so if I multiply u by root x plus h plus root x all over root x plus h plus root x, this is what happens up here. Okay, when you FOIL this guy out, you have root x plus h times root x plus h. Okay, so let me write this over here. Root x plus h times root x plus h is x plus h, right? Then you multiply these guys together, and I'm just going to be a little lazy with my words. This times that minus that times this means you're multiplying the same exact things together and then they're going to disappear. That's the point of this. The middle guys are going to disappear. So if you're FOILing this out, the O and the I go away. They cancel each other out. God is good. And then you have negative, or minus rather, root x times positive root x, which is just minus x all over h. Okay. Now, not h. I take it back. It is all over h, but I still have to factor these guys out. So what I'm going to do is I'm going to keep that h over here and not factor it out. I'm sorry, distribute that out. Root x plus h plus root x. Now, plus 2 is hanging out over here. These guys cancel each other out. So since these guys cancel each other out, we're left with just an h up here over h times something. Now the h's cancel out. How about that? So we have the limit as h approaches 0 of 1 over root x plus h plus root x plus 2. Now I can plug in my 0 and get 1 over, you cancel out, root x plus root x, so 2 root x plus 2. Okay, when I plug in 0 for 2, nothing happens. Not done quite yet though, because I have to plug in 4 to root x, or to regular x. That's going to be 1 over 2 times root 4 plus 2, which is going to be, I'm out of space, 1 over 2 times 2, so 1/4 plus 2 is 2 1/4. So kind of a messy problem. Not the prettiest problem in the world, but yeah, that's how you do it. Gross stuff. F of x equals x cubed minus 3 over x, and f prime of x, oh, it gives me the derivative, equals 3x squared plus 3 over x squared. Find the equation of the tangent line at x equals 2. So this is some kind of weird function, and my job, I don't know what the function looks like, but my job is to find the tangent line at some x equals 2. And now this might be a completely inaccurate drawing, but that's fine. I need a straight line that has a slope of the tangent line and goes through a specific point. So what we need is, if we're thinking y equals mx plus b thoughts, which is what I'm going to do, what we're thinking is we need a slope. Well, the derivative gives us slope. So what we're going to do first to get my slope is we're going to take the derivative, which was given to us, and we're going to plug in 2. So the slope is going to exist at f prime of 2, which means 2 times, oh my gosh, 3, oh boy, 3 times 2 squared plus 3 over 2 squared. Ugh. So that's going to be 3 times 4, which is 12, plus 3 over 4, which is 3/4, so 12 3/4. Okay? And if I wanted to, I can make that 51 over 4. Maybe we'll do it that way. Okay? Now we have our slope. What I don't have is I have a y-intercept. I don't even have a point. I have part of a point. So the way I find the other part of the point is I take 2 and plug it into the original equation to get the y value of my point. So let's quick do that. F of 2, not f prime, but f of 2 is going to be 2 cubed minus 3 over 2, which is going to be 8 minus 3 over 2. So 8 minus 1.5 is going to be 6.5, so 13 over 2. So now I'm kind of thinking, I don't like slope-intercept form anymore. I'm going to go with point slope because I can. Point slope is y minus y sub 1 equals m times the quantity x minus x sub 1. So I'm going to go that route. You're my m. My point is going to be x sub 1, y sub 1. You're my x sub 1, and you're my y sub 1. So if I wanted to turn all of this information into that, I would have y minus 13 over 2 equals m, which is 51 over 4 times x minus 2. Now I did point slope form because I'm lazy and it's easier and I'm out of space. If you needed to turn in that into slope intercept form, then you would do some distribution, you would add 13 over 2 to both sides, and it would all work out in the end. But you know what? This is my problem and I'm doing point slope form and you can't tell me what to do. Which of the following gives the derivative of the function f of x equals x squared at the point 2, 4? Well, by definition, the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So h approaches 0, which eliminates u. You don't even have a limit, so we're getting rid of those guys. Okay. Now, f of x plus h means I'm going to take f of x and replace every x with x plus h. So you become x plus h squared minus f of x is just x squared, so x squared all over h. And it's the limit as h approaches 0 of that. Now, I could take this one step further because they want me to use the point 2, 4. Okay, I only care about the x value. So this is going to become the limit as 2 plus h squared minus 2 squared all over h. Which, looking at my options, appears to be u. Okay, so kind of a weird problem. You don't have to do too much. You just have to set it up. And yeah, we're done. F is continuous for x is in between a and b, so you got some weird interval going on, but not differentiable for some c. So you can't take the derivative at c, and c also lives in between a and b. So you got x living in between a and b, you got c living in between a and b. So basically you have x equals c, some point that you're going to plug in. It's not differentiable at that point. Which of the following could be true? All right, so we need to find out which one of these is true. So if it's continuous on a to b, a says x equals c is a vertical asymptote. That is not true. A vertical asymptote implies that it's not continuous, and it is continuous, so a won't work. The limit as x approaches c of f of x can't equal f of c. That's also not true because that also implies discontinuity. You can't have that either. The graph of f has a cusp at x equals c. Well, a cusp is a point where the function is continuous but not differentiable, right? So c is going to be my guy for this one, okay? F of c is undefined, would imply, again, some kind of asymptote or something like that, and therefore it's not none of the above. So c is the only one that makes sense, again, because a cusp is a point where the function is continuous but not differentiable. Which of the following functions is not differentiable at x equals 1? All right, well, things that are not differentiable are when you have a cusp or a sharp corner at that point. If I were to graph A, okay, there's no sharp corners anywhere. If I were to graph B, it looks like this, but more importantly, it looks like this at x equals 1. At x equals 1, I get a sharp corner, which means B is my guy that's not differentiable at x equals 1. C is a cubic, you're a line. All three of these guys are differentiable everywhere, but B isn't because of that sharp corner at x equals 1. The graph of f of x shown above consists of a semicircle and two line segments. There's my semicircle, there's my line segments. F prime of 3 equals what? Well, f prime means derivative, and the derivative means slope. So if I go to 3, The derivative at that moment appears to be a perfectly straight line where the slope is a positive 1. So my answer is D. So that's basically it. I mean, you're basically being asked what is the derivative at that moment. What is the slope at that moment? 3, and my slope is 1 right at that moment. That's it. For the function f of x equals the square root of x, where does the derivative fail to exist? Well, with square roots of x's, you're looking at a graph that looks like this. Okay, like that. All right. Now, this is continuous from 0 all the way unto infinity. However, wherever you have a cusp or a sharp corner, it's not differentiable, which means if it's not differentiable, you can't take the derivative. Right here at the very beginning at 0, you have a cusp, which means it fails to give you a derivative if you have 0. Now, again, if you were to, I don't know, I don't believe you, then do this. You take that and you take the limit as h approaches infinity. You do that whole thing and plug in 0 and find out that it's not going to be able to be done. But in this case, if I see graphically that there's a cusp or a sharp corner at a specific spot, the derivative will not exist, and that happens here at 0. All right, kids, things get a little bit easier. We're talking about the power rule right here. The power rule says that if you have some constant times x to the n, and you take the derivative of that, you drop the n down, and then subtract 1 from n. So basically what I do is I take my 3, right? I multiply it to 5, giving me 15. X stays x, and drop the 3 down to a 2. And so the derivative of f of x is going to be f prime of x equals 15x squared. That's it. Find the derivative of 7 times the square root of x. This requires the power rule. The power rule says that if I take the derivative of some constant times x to the nth power, what I do is I take that n, multiply it to c, and then subtract 1 from n, like so. Now, this doesn't look like x to the nth power. However, if I change the square root of x into x to the 1/2, now I'm good. So what I'm going to do is I'm going to take that n, I'm going to drop it down and multiply it to the 7. So I have f prime of x is going to equal 1/2 times 7x, and then I'm going to subtract 1 from 1/2. Okay, so half of 7 is 7 over 2, and 1/2 minus 1 is negative 1/2. Now that's no good. I can't have a negative exponent, so what we do is we take any negative exponent and drop it to the other side of the fraction bar. So now you become 7 over 2 x to the positive 1/2. And just because I like things being a little bit cleaner than this, let's turn x to the positive 1/2 back into the square root of x, and you have 7 over 2 times root x, which is going to be a. So when you have a radical like we have here, turn the exponent into a rational exponent. You still follow the same rules, and you'll get your guy. All right, boys and girls, we have ourselves the derivative of negative 2x to the negative third. This requires the power rule. The power rule says that if you take the derivative of some number times x to the nth power, drop the n down and multiply it to c, and then subtract 1 from n, right? No different here, okay? F prime of x is going to have me take that negative 3 and drop it down and multiply it to negative 2, like that. X to the negative third then, minus 1. So this becomes positive 6, x to the negative 4, which I guess that's just how they want us to leave it. Normally I would write it out like this, but since I made ChatGPT do all of the work for me, it kept it like that. No matter, A is going to be the answer. Fun stuff. Find the derivative of f of x equals 4x to the fifth at x equals negative 1. This requires what's called the power rule. The power rule says that if you take the derivative of some number times x to the nth, you are going to take that n, multiply it to c, and then subtract 1 from n. So that's not going to be any different here. I'm going to take 5 and multiply it to 4, so f prime of x is going to be 5 times 4 x, and then I'm going to do 5 minus 1 because you subtract 1 from that 5. And so f prime of x is going to be 20 x to the 4th. Now I'm going to take my x and make it -1. So f prime of -1 is going to equal 20 times -1 to the 4th power. -1 to the 4th power is just 1, and 20 times 1 is 20, so the answer in this case is B. Write an equation for the line which is tangent to the graph of f of x at the point where x equals 2. So I have some weird looking graph, and I don't know how accurate this is. This might not be accurate at all. But at some point on the original graph, wherever you have 2, you get 5. What I want to do is I want to find the equation of a line tangent to that point. What do I know? Well, what I know is the derivative is f of x equals 1 over x. So the derivative at this point 2 is going to give me the slope. So they want me to write this out in slope-intercept form, so let's find the slope. Here's my derivative. F prime of x is my derivative, and it's 1 over x. So my slope is going to be f prime of 2, which is going to be 1 over 2. So what I have so far is a y equals 1/2 x plus b. I don't have my y-intercept. Oh, but you know what I have here? I have here the fact that if I plug in 2, I get 5. So I have the point 2, 5. 2 is an x, 5 is a y. So 5 equals 1/2 times 2 plus b. 5 equals half of 2 is 1 plus b, subtract 1, and b is going to equal 4. So putting this all together, using the information that we have, y equals 1/2 x plus 4 is going to be my equation. That is the slope of the tangent line at the point x equals 2. And that's going to be u. All right, let's take the derivative of this function here. Now, what we have a bunch of times is power rule, power rule, power rule. Power rule says that if I were to take the derivative of something times x to the nth power, right? If I were to take the derivative of that, what you're going to do is drop the n down and multiply it to c, so n times c, and then subtract 1 from n. So it's going to look like that. That doesn't really look like that, though. If you're like, well, what about square roots? What do I do? It's an easy fix. What we're going to do is we're going to change the square root of x into x to the 1/2. Okay? 3 is going to stay 3. We're going to take the cube root of x and turn that into x to the 1/3, and 2 stays 2. So now that I have these as number exponents, I can drop the 1/2 down and subtract 1. Drop the 1/3 down and subtract 1. All right, we'll get to that too in a minute. So f prime of x is going to be 1/2 x to the 1/2 minus 1 is -1/2. Okay, now we're going to bring down the 1/3, so plus 1/3 times the 3 that's already there. X to the 1/3 minus 1 is -2/3. Okay. Now, the derivative of a constant number disappears, goes away, gone, donezo. So that makes life easier. Let's clean this up a little bit. Okay, so we'll take 2 steps to clean this up. F prime of x is going to equal negative exponent. Let's drop it down with the 2. So 2 times x to the 1/2. Okay, 1/3 times 3 is just 1. So we'll pretend that that's not even there. And then we'll drop this down to the bottom and make that x to the 2/3. Now let's clean this up one more time by turning it back into its radical form. So 1 over 2 times the square root of x plus 1 over the cube root of x squared. Okay, so everything is now done. Everything is clean. Everything is lovely. I'm happy. That's my answer. Take the derivative of f of x equals 1 over the square root of x plus 3 over the fifth root of x squared. This is going to use the power rule. Now, the power rule says that if I were to take the derivative of something in the form of whatever times x to the nth, you drop the n down and multiply it to that c, and then you subtract 1 from n. This, though, and these guys don't look the same at all. So let's change f of x using two steps. Let's turn this into 1 over x to the 1/2. So now that I have the exponent, okay, that's good. And let's turn this into 3 over x to the 2/5. Okay, now I still can't apply this rule because this rule only works if things are in the numerator. So how can I fix that? Well, let's write this out as f of x equals, bring both of you upstairs and make the exponents negative. So 1 over x to the 1/2 is going to be x to the negative 1/2. Plus 3 over x to the 2/5 is going to be 3x to the negative 2/5, like so. Now I can take the derivative. Now I can say that f prime of x is going to have me dropping this down and subtracting 1. Dropping this down and subtracting 1. So dropping down the negative 1/2, okay, x to the negative 1/2 minus 1. I'll clean that up in a bit. Okay, plus drop down the negative 2/5 multiplied to that 3 that's already there, x to the negative 2/5 minus 1. Let's clean this up using two steps. F prime of x is going to equal negative 1/2 is still there. Okay, x to the negative 3/2, because 1/2 minus 1 is negative 3/2. You don't do much. Negative times a positive is a negative, so that's going to be negative 6 over 5. And negative 2/5 minus 1 is negative 7 over 5. So actually, two steps after this. Okay, I lied. I'm a liar. Sorry. Step number 1, let's move the negative exponents downstairs. So negative 1 over 2x to the 3/2 minus 6 over 5x to the positive 7/5. And let's clean that up by saying f prime of x equals negative 1 over 2, and we'll do the square root of x cubed, okay, that's the 1, minus 6, oh boy, over 5, the fifth root of x to the 7th. So let me write it out up here. That looks awful. That looks awful. Let me write it out up here in a different color. F prime of x equals negative 1 over 2 square root of x to the 3rd minus 6 over 5 fifth root of x to the 7th, I believe it was. Yeah. So definitely not the prettiest problem in the world, but we did it. Take the derivative of y equals 1 over x to the 3rd minus a half x to the 4th plus ex squared. Now, this is going to use the power rule 1, 2, 3 times. The power rule says if I were to take the derivative of some number times x to the nth, okay, bring that n down and multiply it to that c, and then subtract 1 from that n, like so. I can't do this rule yet because I have x on the bottom of a fraction in the denominator, but all I have to do to clean this up is move that x up here and make it 1 times x to the negative 3rd, and then I'm cooking with gas. So this is fine, and even though that e seems scary, trust me, it's fine. Now, the derivative is going to be y prime, or you can call it dy dx. We're going to bring that negative 3 down and then subtract. So that's going to be negative 3x to the negative 3 minus 1. Okay, minus. Let's bring that 4 down and then subtract. So 4 times 1/2 x to the 4 minus 1. let's bring that 2 down and subtract. So plus 2e to the x, or ex to the 2 minus 1. Let's simplify. Negative 3x to the negative 4th. Negative 4 times a half is negative 2, x to the 3rd. 2e is just 2e. 2 minus 1 is invisible 1. Okay, so let's clean this up one more time. Y prime equals this. One more step and we'll be done. Negative 3 over x to the 4th, right? Because x moves to the bottom. Nothing changes here. And again, that invisible 1 is not necessary. And that's what I end up with. Power rule, baby. I love the power rule. It's so bad. It's from a movie called The Wizard. He says power glove, though. Like and subscribe. You are given f of x equals 1/2 x to the 4th minus 4x to the negative 2 plus e, and my job is to find f prime of 3. Well, this is going to use the power rule not once, not twice, but thrice, kind of. The power rule says that if I were to take the derivative of something in the form of some number that I'll call c x to the nth power, okay, I'm going to drop down that n and get n times c of x to the n minus 1. So you drop your exponent down, multiply it to the number that's already there, and take 1 away from your exponent. Now, I can't do that yet. No, actually, I can. Everything's in good shape. I have my, x to the 4th, x to the negative 2, and no x there, so that's going to be all right. It's going to be pretty easy. So f prime of x, okay, has me dropping down the 4 and subtracting 1. So multiply 4 to 1/2, and then I get x to the 4 minus 1. Okay, minus, drop down the negative 2, so I have negative 2 times 4, x to the negative 2 minus 1. And if I take the derivative of e is just a number. The derivative of a constant is 0, so I don't need anything there. So I have a little bit of cleaning up to do. F prime of x is going to equal 4 times 1/2 is 2. Okay, 4 minus 1 is 3. Negative times a negative times 2 times 4 is going to be positive 8, x to the negative 3rd. Now, let's clean this up just a teensy bit more. Let's just make this 2x to the 3rd, and we'll drop that negative exponent to the bottom and make it x cubed. Am I done? Nope, because my job is to find f prime of 3. So f prime of 3 has me substituting 3 for every x. So I get 3 cubed times 2 plus 8 over 3 cubed again. So 3 cubed is 27. 3 cubed is 27. So that's going to be, what, 54 plus 8 over 27 is going to be 54 and 8/27. So I'm not going to lose sleep trying to simplify that. I'm going to let it go like that. Not the prettiest thing in the world, but that's my answer. I like this one. This is going to be pretty fun. Given g of x equals 2x to the 5th plus b, where b is some number, some constant that we don't know, over x squared, find the value of b if g prime of 2 is 180. So what I have to do is I have to take the derivative of this guy. Before I can take the derivative, let me rewrite it out. G of x is going to equal 2x to the 5th. Now I'm going to use the power rule. Okay. This isn't good for the power rule right now because x is on the bottom, so I'm going to move x to the top and make it x to the negative 2 power. Now I can apply the derivative. G prime of x has me dropping this 5 down and multiplying it to 2, so drop the 5 down, multiply it to 2 times x, and subtract 1 from here. So 5 minus 1. Drop this negative 2 down, so plus negative 2 times some b, and then we're going to subtract 1 away from that negative 2, so negative 2 minus 1. Okay, so simplifying that, g prime of x is going to be 5 times 2 is 10, x to the 5 minus 1 is 4, plus, actually minus, so let's get rid of that. Let's get rid of that. Minus 2b, or not 2b, x to the negative 3rd. Shakespeare joke. It's okay. Now what do I do? Well, I know that if I replace x with 2, I get 180. All right, so if I replace x, so g prime of 2 is 180, which means I replace each of these x's with 2. Maybe before I do that, why don't I quick rewrite this so that it looks like that. And now what I'll do is I'll replace every x with 2. So I get 10 times 2 to the 4th, minus 2b over 2 to the 8th. Third, I'm sorry. I accidentally jumped ahead and did it. All right, so let me move this over here where I'm probably going to need the space. We have 180 equals 10 times 2 to the 4th is going to be 10 times 16 minus 2b over 8. So 180 is going to equal 160 minus b over 4. Now it's a two-step equation. Subtract 160, subtract 160. On the left side, you get 20 equals negative b over 4, right? Multiply both sides by negative 4. Multiply both sides by a negative 4. That crosses out along with the negatives, and b equals negative 4 times 20 is negative 80. What a strange problem. I liked it though. You had to think about it a little bit, but you know, that's how you do it. Power rule, fun. Let f of x equal x cubed plus 2x minus 5. What is the x coordinate of a point where the instantaneous rate of change of f is the same as the average rate of change of f on the interval negative 1 to 1? Whew. Okay, all right. Let's do this. This is a doozy. Let's find the average rate of change first, okay? And I like to say AROC. The average rate of change is found by doing f of b minus f of a over b minus a, all right? You would be my a, you would be my b. So finding f of a would be me finding f of negative 1. Okay, and that would be negative 1 cubed, which is negative 1, plus 2 times negative 1, so minus 2, minus 5. So that gets you negative 8. F of regular 1, f of b, which is f of regular 1, is going to equal 1 cubed, which is 1, plus 2 times 1, which is plus 2, minus 5, and that's going to be negative 2. So f of b minus f of a is going to be negative 2 minus negative 8 over b minus a is going to be 1 minus negative 1. So you become plus sign, you become plus sign. That is 6 over 2, which is 3. So the average rate of change is 3. All right. So what I need is I need to find the x-coordinate of a point where the instantaneous rate of change of f is 3. Instantaneous rate of change is derivative. Now, I'm not going to use the definition of the derivative because I now know the power rule. So I'm going to say f of x, I'm just rewriting f of x equals x cubed plus 2x minus 5, just rewriting. I'm going to take the derivative of that using the power rule, all right? So drop down the 3, subtract 1 from 3, and that's what the derivative of x cubed is, plus 2x. The derivative of 2x is just 2 because you would drop down the 1, invisible 1, and then get x to the 0th. And the derivative of a constant is 2. Now, we want our instantaneous rate of change to be 3. So 3 is going to equal 3x squared plus 2. And now I have to solve this abomination for x, which means, you know, it's going to be bad. Minus 2, 1 equals 3x squared, right? Divide by 3, divide by 3. 1/3 equals x squared. Square root both sides, and technically we have a plus or minus, but I don't think they want us to do that here. They just want us to have the positive version. but this is going to be super annoying. Now I have x equals the square root of 1 over 3. They don't have that as an option. So you view this as x equals the square root of 1 over the square root of 3, which becomes 1 over the square root of 3. They don't have that as an option. So the way you get around that is you take that 1 over root 3, you multiply the denominator and the numerator by root 3 over root 3 to rationalize it. That gets you root 3 over root 3 times root 3, which is root 3 squared, which is just 3. And my answer is A. So that is a very, very, very tricky and very, very, very challenging problem. But we did it. And we had fun, didn't we? We did. Find the equation of the line tangent to f of x equals x cubed plus 2x squared minus 4 at x equals -1. I don't know what this looks like. But I know it's a cubic, and I know at some point x is going to equal -1, and I'm supposed to find the line tangent to that at -1. Well, what do I know? I know that the slope of the tangent line is found by taking the derivative. So in order to find the slope, I have to take the derivative of u. So slope equals f prime of x, which is going to involve me taking the power rule. Drop the 3 down, subtract 1. So drop the 3 down, subtract 1, u become u. Drop the 2 down, multiply it to 2, so I get 2 times 2 is 4. Subtract 1, x to the invisible 1. If I were to take the derivative of -4, I get nothing. Now, I care about my slope when x is -1, so I have to take f prime of -1 and plug in -1 to both x's. 3 times -1 squared plus 4 times -1. That gets me 3 times regular 1 minus 4, which is going to be -1. So my slope is -1. So the picture that I drew here, not that accurate. That's all right. It's not literally the picture that I care about, it's the equation. I have my slope. What I don't have is a point. I do have the x value of a point. So in order to find the y value of the point, why don't I plug that -1 into that guy and find my y value? So my y value is going to be f of -1, which is going to be -1 cubed plus 2 times -1 squared minus 4. -1 cubed is -1. -1 squared is 1, so 2 times 1 is plus 2, and then minus 4. -1 plus 2 minus 4 looks to be -3. So my y value is -3. So what I have is I have a slope of -1 and the point of -1, -3. I'm going to use point slope form, y minus y sub 1 equals m times the quantity x minus x sub 1 to build my equation. All right, so y minus negative, so you would be my y sub 1, you would be my x sub 1, you would be my m, y minus -3 equals m, which is -1, times the quantity x minus x sub 1, which is -1. And cleaning that up just a little bit more, y minus -3 is y plus 3. I don't need the -1 part, I just need the negative. And x minus -1 is x plus 1. And that's a reasonable answer. And if you wanted to make that slope-intercept form, then distribute the negative and subtract 3 from both sides. Either way, this is acceptable, and this is going to be my slope of the tangent line of that cubic function at x equals -1. What is the derivative of f of x equals log base 3 of x with respect to x? Generally speaking, the derivative of a log base b of x is going to be 1 over x times the ln of whatever that base is, right? So this is a very straightforward problem. Since I have log base 3 of x, I could say the derivative of f of x is going to be f prime of x equals 1 over x times the ln of 3. Now, if I wanted to, I could throw in ln of 3 into a calculator and get some gross, terrible number that I really don't care about. but we're going to leave it like that. So this is a very straightforward problem. You just have to have this memorized, and keep in mind that if this was log of x, that would be invisible 10, but other than that, this is, yeah, just following the rules. So there's your derivative of a log. Find the derivative of f of x equals 3 times sine of x. Generally speaking, the derivative of sine of x is cosine of x. So if you throw a number in front of it, I might as well just throw that number out here because it makes no difference, and then you throw the same number out here. So the derivative of 3 sine x is going to be 3 cos x. So very straightforward. A is going to be my answer for this one. So pretty simple stuff. Find the derivative of g of x equals negative 5 cos x. The rule for the derivative of a cosine is the derivative of cos x is going to equal negative sine x. So if I were to, let's scooch this over, let's do some clever work here. If I were to throw a negative 5 in front of cos x, I might as well just take that negative 5 out there because it's just a coefficient, and my d dx has nothing to do with it. And so I would multiply this whole thing by negative 5. So the double negative would make the whole thing positive, and I would get 5 sine x. So the derivative of negative 5 cos x is positive 5 sine x. And that's going to be A. So trig stuff is just mostly memorization once you're dealing with this section right here. And yeah, that's basically how you do it. Pretty simple stuff. Find the derivative of f of x equals 6 cos x minus 2 sine x. Well, let's write out the derivatives of sine and cosine. The derivative of sine x is positive cos x. The derivative of cos x is negative sine x. Now, when you throw coefficients in front of it, it doesn't change anything. You keep the coefficients there and then take whatever derivative that you're dealing with. So f prime of x is going to be 6 times the derivative of cosine x. So since the derivative of cosine x is going to be negative sine x, I just multiply 6 to it, right? Then we have minus 2. The derivative of sine x is just going to be cos x, right? So when I simplify things and make things look a little bit prettier, this would be negative 6 sine x minus 2 cos x, and that is going to be C. So yeah, you just have to have these memorized. Remember that the one is positive, the one is negative, and when I have coefficients in front of them, it doesn't really change anything. You just kind of carry them along and take the derivative like you normally would, and C is going to be our guy for that one. Pretty simple. Find the derivative of 5e to the x plus x to the fourth. All right, well, first off, this section is focusing on the e to the x stuff. Really difficult stuff right here. The derivative of e to the x, get ready, is e to the x. So, okay, so that's going to make life really simple. If you're looking at x to the fourth, don't overthink it. That's just power rule stuff. That's d dx of x to the nth means you just drop down the n and subtract 1 from the n. So this is e to the x, nothing changes. This is power rule. So if I were to multiply 5 to e to the x and then take the derivative of 5 to e to the x, nothing changes. So f prime is going to equal 5e to the x so far. Now this is power rule. You drop the 4 down, so plus 4 times x to the 4 minus 1 is going to be 3. And you end up with 5e to the x plus 4x to the third, which is going to be a. So yeah, no trickery. I mean, you know, this section is focusing on e to the x and ln's and sines and cosines and stuff like that. But this is just bringing back an old friend called power rules, so we're doing that too. Fun stuff. All right, take the derivative of root x plus 6e to the x. All right, so a couple things are happening here. We've got power rule going on right there, and we've got e to the x. First things first, the derivative of e to the x is extremely difficult. It's e to the x. So I lied. It's not extremely difficult. It's actually the easiest thing on the planet. So I said this is power rule, right? And power rule is if you take x to the nth power, you drop down the n and you take 1 away from n, right? And you might look at that and say, that doesn't look like that. No, it doesn't. But if I rewrite the square root of x to make it look like x to the 1/2, then that does look like that. So the gross part is going to be the x to the 1/2. So taking the derivative of that has me dropping down the 1/2 in front of x and then subtracting 1 from 1/2. And that's going to involve a little bit of cleanup. If I were to take the derivative of 6e to the x, the coefficient doesn't change, and e to the x is still e to the x. Easy peasy lemon squeezy. Now this is just the guy that I have to do a little bit of work with. So you become 1/2 x to the negative 1/2 plus 6e to the x, right? Since that's x to the negative 1/2, let's drop that down to the denominator and make that x to the positive 1/2 plus 6e to the x, like so. And let's wrap this puppy up by turning x to the 1/2 back into its root. So 1 over 2 root x plus 6e to the x. And that's going to be our derivative. I was going to say that's going to be our guy and derivative, and it turned into that's going to be our gur. Thanks for watching. Like and subscribe. Evaluate ln of f prime of 5, all of that squared, if f of x equals e to the x. So this is just a really gross problem. Not difficult, just really gross. Work within the innermost parentheses first, and that's f prime of 5. Before I even find out what f prime of 5 is, I need to find out what f prime of x is. So since f of x is e to the x, the derivative of e to the x is e to the x. So f prime of x is going to be e to the x. Nothing changes there. If I were to take 5 and plug that in, that would be f prime of 5 equals e to the 5th. Now, don't run to the calculator and try to find out what that is, because now that I have f prime of 5 is e to the 5th, I could do a little bit of work up here. So I have ln of f prime of 5. I'm going to replace that with e to the 5th. And of course, all of that is being squared. Now, the reason why I didn't find out what e to the 5th was is ln of e to the 5th simplifies, and the 5 is all alone by itself. Ln of e to the any number is that number. Okay? Ln of e to the x is x. It just cancels out. So I have 5 squared, and 5 squared is 25. So a very bizarre problem. I mean, these are the types of problems that are designed to see if the kids who get 5s on the AP exams can figure out what this is asking. And all this is asking is you to do a bunch of useless stuff and end up with a really nice number you don't need a calculator for. And that's my guy. Given y equals log base 5 of 5 to the 5x, find dy dx. Now, lots of logs and lots of 5s, okay? But here's the general rule, okay? Log base b of b to the x, the log base b and the b cancels out, and you're dropping down just the x. Now, I know this doesn't look exactly like this, but log base 5 of 5 to the stuff, the log base 5 of 5 just cancels each other out. And I can drop down 5x. So now I just have power rule, and that's it. The derivative of 5x means you just get rid of the x, and you're left with 5 and only 5. And that's my answer. So this is a weird problem for sure, and it made us use a couple log rules, but yeah, that's how you do it. Not bad. All right, boys and girls, we have ourselves product rule. Now, the product rule is when you have to take the derivative of a function times another function, and you have to differentiate things separately. You're not dealing with coefficients here. You have two functions multiplied together. Now, this is the way that I do it. And some teachers, some professors might do it differently. Some might do it the same way I do. I view my two functions as u times v. So I would call u, I would call u v. And so the derivative of that would be u prime v plus v prime u. Some professors might call this f of x, or teachers might call this f of x, g of x, or just f and g. I don't like doing that because you're usually given f and I don't want to do double whammies, so I like sticking with u and v. So you take the derivative of the first guy, multiply the second guy, plus the derivative of the second guy, multiply the first guy, right? So I already called what I called this. Okay, so the derivative h prime of x is going to be the derivative of u. So here is u. The derivative of u is using the power rule, and the power rule applied to x cubed is going to be 3x squared. Okay? And I'm going to multiply that to v as is. So cosine x remains cosine x. Then we add. The derivative of the second guy is going to be the derivative of cosine, which is negative sine x, like so. And then you keep the first guy as is. So times x cubed. And now it's just a matter of cleaning things up. Okay, h prime of x is going to equal 3x squared cosine x plus, let me move this x cubed to the front and also make this whole thing negative. So maybe not a plus. Let's get rid of the plus like that. So let's make it minus x cubed sine x. So 3x squared cos x minus x cubed sine x is going to be a. That's going to be our guy. Find the derivative of the following. Y equals 3x squared minus 2x, all in its own parentheses, times a brand new quadratic, x squared plus 3x minus 4. Now, there's two ways that you can handle this. You can FOIL all this out and deal with the polynomial. I'm not going to do that. What I'm going to do is I'm going to use the product rule. Now, the way I handle the product rule is this. You take the derivative of two things, and I like to call them u times v. So u would be my u, and u would be my v. This first function is u, the second function is v. Now, to take the derivative of something times something else, you take the derivative of the first function, multiply the second function as is, plus the derivative of the second function, multiply the first function as is. Okay, so I'm going to leave this like that. All right, so let me kind of color code things a little bit. I will call u blue. So if I want to find out what y prime is, it's going to be the derivative of the first guy. So lots of parentheses. I'm going to keep those parentheses there. Okay, u prime is going to be the derivative of 3x squared minus 2x. So this is power rule the whole time. The derivative of 3x squared is 6x minus the derivative of 2x is just minus 2. Okay, so that's u prime. And then v, we'll do purple. We'll do purple for v. Regular v is just going to be regular v. X squared plus 3x minus 4. Okay, then we're going to add v prime, which is going to be the derivative of the second guy. So the derivative of the second guy is power rule, power rule, power rule. The derivative of x squared is 2x. The derivative of 3x is 3. And the derivative of a constant just goes away. Okay, and that was v prime. Then we multiply all of that times the first guy not changed at all. So that was 3x squared minus 2x. Now I'm going to leave this as is. I know it looks sloppy, but the purpose of the product rule is to avoid foiling. And so why would I FOIL twice if my whole goal was to avoid foiling in the first place? But that's going to be my answer right there, is this ugly mess. That's how you do product rule if you're allowed to just do it without having to FOIL anything out. Okay? Gross looking, but that's it. Find the derivative of the following. You have x to the negative 2 times e to the x cubed plus e. This is a function times a function. All right, x to the negative 2 multiplied to this parentheses. And what I don't want to do is distribute that out, because then I'm probably making myself more of a mess. Or maybe I'm not. I don't know. I'm going to leave this as is, because the goal of this section is to deal with product rule anyway, so I'm going to view this as product rule. The way I handle product rule is if you have a function times a function, I like to call it u times v, you take the derivative of the first function and multiply it to the second function as is. Then you add the derivative of the second function multiplied to the first function as is. So following these steps, I would say that y prime is the derivative of the first function. So the derivative of the first function is me taking the derivative of x to the negative 2, which is just power rule. So you drop down the negative 2, subtract 1 from negative 2, and you have that. Okay. Now you keep the second function as is. So x cubed plus 3. Just like that. Then you add the derivative of the second function. Now I know what you're thinking. E to the x, that's not e to the x. That's e. You're treating e like a constant. So this is power rule. So you drop down the 3, you multiply it to the e that's there, and you subtract 1 from 3, making it x squared. Then you take the derivative of 3, which is nothing. So we'll leave that as that. Okay? Keep that multiplied to the derivative of, the regular function as is. And it gave it to us like that, so I wonder if this is something where if you saw this on a test, they'd leave it with the negative exponents. I don't feel right. I don't feel right doing it. So I'm just going to simplify it one last step. All right, I'm going to keep negative 2 upstairs, right? I'm going to move x cubed to the bottom, and I'm going to keep x cubed plus 3 in parentheses upstairs. I'm going to add, I'm going to keep that up top, 3x squared in the numerator, move x to the negative 2 to the bottom, and I'm going to answer it that way because it looks a little bit nicer. I'm not going to bother trying to combine fractions because I don't want to. These are my videos and I'm sticking with that. So, I don't know. You might see this as an acceptable answer. That just looks a little bit better, so I'm sticking with that. Yeah, that's product rule for you. Fun stuff. Given that h of x equals f of x times g of x, f of 3 is 7, g of 3 is 2, f prime of 3 is 4, and g prime of 3 is 10, find f prime of 3. All right, well, we have all of these f of 3's, g of 3's, f prime of 3's, g of 3's, and we're basically being told, hey, look, product rule, let's be cute with it. Okay, well, product rule in its general form says this, and I'm going to use the actual form. If you watched all of my videos, I like to use u's and v's, but since they're giving me the f's and g's, I'm going to keep it that way. So h prime of x is going to be the derivative of the first guy multiplied to the second guy as is, plus the derivative of the second guy multiplied to the first guy as is. Which means if I were to plug in 3, it would be f prime of 3 times g of 3 plus g prime of 3 times f of 3, like that. So h prime of 3 would be f prime of 3, which is 4, times g of 3, which is 2, plus g prime of 3, which is 10, times f of 3, which is 7. Now it's just a PEMDAS problem. H prime of 3 is 8 plus 70, and finally h prime of 3 is 78. So not a typical product rule type problem, but you know, it's all good, as the kids say. It's all good. Given that y equals ln of x over x, find dy dx using the product rule. Well, this is what the product rule says, and this is how I do it. Okay, if you have two functions multiplied together, you take the derivative of the first function, you multiply it to the second function as is, then you add the derivative of the second function multiplied to the first function as is. This doesn't look like that. That looks like something divided by something, not something times something. But if I were to pretend that there's an invisible 1 right there and move it to the top here by using a negative exponent, then I'm cooking with gas, baby. So that's exactly what I'm going to do. I'm going to make that x to the negative 1, move it in the numerator, and then multiply it to ln of x, and then apply this rule over here. I will let u be my u. I will let u, ln of x, be my v, and then follow these rules. So dy dx, right, the derivative, is going to equal the derivative of that x to the negative 1. This requires the power rule. So you drop down the negative 1, and then you take 1 away from that negative 1, like so. Then you multiply the ln of x as is, so you're still ln of x. Let's keep it wrapped in parentheses because it looks pretty that way. Now we're going to add the derivative of the second function. The derivative of ln of x is 1 over x. Multiply that to the first function as is, the original u, which is x to the negative 1. Now there's lots to clean up here, and so that's what I'm going to do right now. All right, dy dx is going to equal negative, I don't need that, 1, so negative x to the negative 2 multiplied to ln of x. I don't like negative exponents, so I'll leave u as 1 over x, and I'm going to turn u into 1 over x. All right, like I said it already, I don't like negative exponents, so I'm going to make u negative, move u to the bottom, 1 over x squared times ln of x, plus, now these are two fractions multiplied together, so 1 times 1 is 1, x times x is x squared. Now let's multiply that ln of x to that 1 up there so we can combine these fractions. dy dx equals negative 1 times ln of x is ln of x all over x squared plus 1 over x squared. Now, since these are two fractions that have the same denominator, we might as well just combine them. So dy dx is going to equal negative ln of x plus 1 all over x squared. So not the prettiest looking guy on the planet, but that's all right. It's not all about beauty. You know, the beauty's on the inside. That counts. That's what I hear. All right, well, anyway, thanks for watching. Like and subscribe. Find the derivative of the following. We've got y equals 5x e to the x, interesting, plus 2x squared e to the x, interesting, minus e to the x. This, boys and girls, is product rule and product rule again. Let me remind you of what the product rule is. The product rule says if you multiply two functions together, and I like to call one u, I like to call the other one v, you take the derivative of the first one, multiply the second one as is, plus take the derivative of the second one, multiply the first one as is. So we are going to do product rule twice. So you'll be my u and you'll be my v, and then I'll do that again. So y prime is going to equal, take the derivative of the first guy, so the derivative of, and again, by the first guy, I mean 5x, so the derivative of 5x is just 5, multiply the second guy as is, so times e to the x, plus take the derivative of the second guy, the derivative of e to the x is just e to the x, and multiply the first guy as is, so 5x. All right, so that's u. We'll clean u up in a bit. Let's do the same thing again. So 2x squared is going to be my u, e to the x is going to be my v. So we're going to add, because that's a plus sign, take the derivative of the first function, so the derivative of 2x squared is 4x, okay, times, keep the second guy exactly the way it is, e to the x, plus the derivative of the second guy, which is e to the x, times, keep the first guy the way it is, 2x squared. Okay. U are just the derivative of e to the x. So minus e to the x, nothing changes. Now I got a little bit of cleanup to do, so let's see if we can clean this up and see if anything combines. There's a strong possibility some stuff will combine. We'll have like terms here. We'll see what happens. 5 times e to the x is 5, e to the x, check. 5x e to the x, so 5x e to the x. All right, so you guys won't combine. You guys will, though. 4x e to the x, so I'll deal with that when I have to. How about 2x squared e to the x minus e to the x? Oh, okay, so several things combined. All right, 5 e to the x minus e to the x is going to be 4 e to the x. Okay, so you combine 5x e to the x, 4x e to the x is going to be 9x e to the x. And then just kind of hanging out all on its own is 2x squared e to the x. That's going to equal y prime. And that is me using product rule twice and then combining like terms. So much fun! Take the derivative of f of x equals x minus 5 over 2x plus 1. This, boys and girls, is the quotient rule. Now, different teachers handle the quotient rules different ways. You may have heard your teacher mention high D low and low D high. It's a rhyme that helps you remember things. Or maybe they use F's and G's. This is what I do. I view the numerator as u and the denominator as v. So d dx of u over v is going to look like this. Now again, whatever your teacher does, whatever letters your teacher uses, it's all going to be the same thing in the end. I do u prime v minus v prime u all over v squared. All right, that is going to be the quotient rule. So now that I know what u is and now that I know what v is, I like to just kind of go off to the side and take the derivative of each one. So u prime is going to be the derivative of the numerator. So the derivative of x is 1, the derivative of negative 5 is nothing, so u prime is just 1, easy peasy. V prime is going to be the derivative of the denominator. The derivative of 2x is 2, the derivative of 1 is nothing, so v prime is 2, easy peasy again. Now v squared is going to be what the denominator is when all is said and done, and that is going to be 2x plus 1 squared. Now, I am not going to FOIL this out. I'm not going to do a perfect square trinomial because every now and then when you throw everything on up here, things simplify and you might be able to cancel stuff out. Does that happen all the time? No. Does that happen sometimes? Yes. So I'm not going to FOIL this out, not yet. So let's set it up. F prime x is going to equal u prime. U prime is 1 times v. V is 2x plus 1 minus v prime, which is 2, u, which is x minus 5, all over v squared, which I'm keeping as 2x plus 1 squared. Okay? Let's distribute that 1, which means nothing happens. Let's distribute negative 2, not 2, negative 2, and we get minus 2x, how nice, plus 10. And that's going to be all over 2x plus 1 squared. You cancel out. 1 plus 10 is 11. So f prime of x is going to equal 11 over 2x plus 1 squared. And I'm going to leave it like that. If you have a teacher or a professor that says, no, you must FOIL it out, great. 4x squared plus 4x plus 1. Here, yippee. I did it for you. But yeah, that's what you would get. Okay? So quotient rule is very important. You're going to see it a lot. This is how I do it. This is how I do. Like and subscribe. Find the derivative of f of t equals t plus 1 over the square root of t. Boys and girls, this is the quotient rule. The quotient rule says if you take the numerator and call it u and the denominator and call it v, then the derivative of the numerator over the denominator is going to be the numerator prime times the denominator minus the denominator prime times the numerator all over the denominator squared. All right, so I like to go off to the side, and I like to say what each thing is, okay? So u prime is going to be t plus 1, well, the derivative of t, which is 1, and then plus 1 is nothing, so u prime is just 1. Okay, I would like to envision v, and I'll just write it down because why not, v as root t, which is actually t to the 1/2. I don't know why I put that root t there. T to the 1/2. So the derivative of t to the 1/2 now uses power rule. Bring down the 1/2, okay, t to the 1/2 minus 1, which is negative 1/2. Okay, drop down that t to the negative 1/2 to the denominator, like that, and turn it back into its square root version, and you're good to go. V squared is going to be the square root of t squared, which is just t. That's nice. So let's put it all together. Okay? F prime of t is going to be u prime v. So u prime was 1. V was square root of t minus v prime, which is 1 over 2 times the square root of t, times u, which was t plus 1. All over v squared, which is t. So this is not going to look pretty at all. That's all right. V prime of t equals 1 times the square root of t is the square root of t minus, let's put t plus 1 in the numerator, so t plus 1 over 2 root t over t. And I think I'm going to leave it like that because who cares? I mean, there's nothing wrong with having, fractions everywhere. Some teachers might not be happy with this, but I'm going to leave it like that. I mean, I guess what you could do is multiply the top and the bottom by 1 over t, and that would help, and then you would end up combining fractions. But I don't know if that's necessary. I'm just going to leave it like that because it's calculus and I'm allowed to. So there you have it. If y equals sine x over regular x, then dy dx equals, well, this is going to use, kids, the quotient rule. The quotient rule says if you take the derivative of something in the form u over v, and sine x would be u and x would be v, so u over v, you would do u prime v minus v prime u all over v squared. So what I like to do is I like to go off to the side. U is sine x, v is x, so u prime would be the derivative of sine x, which is cos x, like that. V prime is going to be the derivative of x, which is just 1, and v squared is going to be x squared, which is x squared. Nothing crazy, nothing fancy. There you have it. So dy dx would be me putting this all together. Dy dx is going to be u prime v, which is cos x is my u prime, v, which is regular x, minus v prime u. V prime is 1. U is sine x all over x squared because it's v squared. Cleaning this up a little bit, dy dx is going to be x cosine x minus sine x over x squared. And there's not much you could do with that. I mean, there's no more that you can simplify. There probably is some clever technique, but that's it. I mean, we did quotient rule. It's a pretty quick problem, pretty basic problem, nothing wacky here. We end up with that as our answer, so there you have it. Determine the x values, if any, at which the function has a horizontal tangent line. Now, a horizontal tangent line means slope is going to equal 0. So what I have to do is I have to find the slope of the tangent line, which means derivative, and then set it equal to 0. Well, this, boys and girls, is quotient rule. So I'll label u and I'll label uv, and the quotient rule says that if I take the derivative of u over v, I get u prime v minus v prime u all over v squared. Okay, so let's do that. Let's find out what u prime is. Okay, so if u is 4x cubed, u prime is going to be 12x squared because of power rule. And if I have negative 10x squared, then that's going to become negative 20x because of power rule once again. V prime is going to be the derivative of 2x, which is 2 because of power rule. And then v squared is going to be 2x squared, which is 4x squared because of multiplying things. Now let's set this all up. Okay, v prime of x is going to equal u prime v, so u prime was 12x squared minus 20x times v, which is times 2x, minus v prime. V prime was just regular old 2, times u, which was 4x to the third minus 10x squared. and that's going to be all over 4x squared. Okay, so let's set this equal to 0, because that's the next step. Let's distribute that. You become 24x to the third minus 40x squared. Let's distribute negative 2 minus 8x cubed plus, that was a close one, plus 20x squared all over 4x squared. Now, whenever you have 0 equals blah, blah, blah over stuff, that bottom stuff doesn't matter. Get rid of it. Because you would just multiply both sides by 4x squared and then it's gone. So 0 is going to equal, let's combine like terms. Okay. So 24x cubed minus 8x cubed is going to be 16x cubed. Positive 40x squared plus 20x squared is going to be minus 20x squared. Okay. Let's factor out a 4x squared. And so that becomes 0 equals 4x squared. And then we're left with 4x minus 5. Okay, so over here in purple, where I have a little bit more space, we can do the zero product property and set 4x squared equal to 0. Divide both sides by 4, which keeps it at 0. Take the square root of both sides, which is going to be plus or negative square root of 0. And x is going to equal plus or negative 0, which is just 0. So we got a double root going on there. Okay, easy peasy lemon squeezy. Then over here, and we'll use green because we haven't done that yet, I have 4x minus 5 equals 0. Add 5, so 4x equals 5. Divide by 4, and x equals 5 over 4. So my two x values that give me horizontal tangent lines are going to be x equals 0 and 5 over 4. And it was the quotient rule that gave us that. Thank you, quotient rule. Thank you so much. What is the derivative of f of x equals ln of x over sine x with respect to x? This, boys and girls, is the quotient rule. So I'll label the numerator u and the denominator v. And I'll remind myself that the quotient rule says that the derivative of u over v is u prime v minus v prime u all over v squared. So let's find each one. All right. U prime is going to be the derivative of ln of x, which is 1 over x. V prime is going to be the derivative of sine x, which is cos x. And v squared is going to be sine squared, so sine squared x. Okay, let's build it. Let's build it. ddx of u over v, so I'm going to call it f prime of x. Don't know why I did that. Let's call it f prime of x is going to equal u prime v, so 1 over x times v, which is sine x, minus v prime, which is cos x, times regular u, which is ln of x, all over v squared, which is sine squared x. So f prime of x is going to equal, let's do sine x over x minus cos x ln of x over all over sine squared x. You know, I look at this and I'm like, I don't see any point in continuing and trying to make this into one big fraction and then multiplying the top and the bottom by 1 over sine squared x. So we're going to go with this. I think that's fine. You know, these problems, they just get sloppy and they don't look much prettier once you keep going. So I'm going to keep it like that. That's my guy. And that's my answer. Quotient rule. Use the quotient rule to derive the derivative of tangent of x. All right, well, first things first, what is tangent of x? Tangent of x is the same as sine x over cos x. right? So I'm going to need the quotient rule for this. So if I label u and I label v, the quotient rule would be the ddx of u over v is u prime v minus v prime u all over v squared. In other words, the derivative of the top times the bottom minus the derivative of the bottom minus times the top all over v squared. So let's see what happens. So let's take the ddx of sine x over cos x. All right, let's do that. Just writing it out. Okay, so that's going to be u prime v. Let's actually go over here and find out what u prime, v prime, and v squared is. U prime is going to be the derivative of sine, which is cos. Okay, very simple. And v prime is going to be the derivative of cos, which is negative sine, also very simple. And then v squared is going to be cosine squared, so we'll say cos squared. Now that we have that, let's plug it all in. U prime is cos x, so cos x times v, which is cos x again, so cos squared, minus v prime, which is negative sine x, so there's a double negative right there, very interesting, times u, which is sine x, all over v squared, which is cos squared x. Okay, cosine times cosine is cos squared x, minus a negative, so plus sine x times sine x is sine squared x. And that's all going to be over cosine squared x. Now, I know what you're thinking. Oh, a cos and a cos, they cancel out. No. This is actually what happens. There's a Pythagorean theorem identity that says cos squared x plus sine squared x equals 1. That comes from the unit circle back in pre-calculus, boys and girls. So this whole numerator turns into 1. And that's all over cos squared x. Well, we know also from pre-calculus and geometry and all that good stuff that 1 over regular cosine is secant. So 1 over cos squared is secant squared x. So after all of that, the derivative of tangent x is secant squared x. And we did that using the quotient rule. Isn't that neat? Use the quotient rule to derive the derivative of secant x. All right, well, what is secant x? Secant x is 1 over cosine x. So what I'm going to do is I'm going to label u, I'm going to label uv, and I'm going to remind myself that the quotient rule is the derivative of u over v is u prime v minus v prime u over v squared. So let's go off to the side and say, all right, well, using that information, u prime is going to be the derivative of 1, which is nothing. V prime is going to be the derivative of cosine, which is negative sine x. And then v squared is going to be 2 cosines, one multiplied to the other, so cos squared x. All right, so let's put it all together. The ddx of secant x is going to equal u prime v, so 0 times cosine x, that's going to make life easy, minus v prime, so minus negative sine, so a double negative right there off the bat, u, which is 1, all over cos squared x. Like that. All right, so things cancel out. Okay, u go away. Double negative is going to become positive sine x over cos squared x. So let's kind of split this up into something slightly more manageable. All right, I have one sine up here I have two coses down there, so let's just, for this example's sake, split it up like this. Okay, this is perfectly fine. Because I'm trying to think like, all right, well, there's got to be a way that I can simplify this, and there is. So if I say sine over cos, I know that sine over cos is tangent. And I know that 1 over cos is secant. And so when all is said and done, I have my answer. The derivative of secant x is tangent x secant x. So, or some teachers might say secant x tangent x. It's the same exact thing. But when all is said and done, that's what I get. And we figured that out using the quotient rule. Fun, fun, fun. Use the quotient rule to derive the derivative of cosecant x. Well, what is cosecant x? Well, that would be 1 over sine x. And if I'm going to use the quotient rule, I'll label u and I'll label u v and remind myself that the derivative using the quotient rule of u over v is going to be u prime v minus v prime u all over v squared. So let's find out what u prime, v prime, and v squared are. U prime is going to be the derivative of 1, which is nerfing. V prime is going to be the derivative of sine, which is regular cosine. And then v squared is going to be sine squared, so sine squared. So let's put it all together. All right. The derivative of cosecant x is going to be u prime v, so 0 times sine x, that'll be nice, minus v prime, so cosine x, u times 1, all over v squared, which is sine squared x. So let's make things go away. 0 times sine x goes away. Okay. Negative cosine x times 1 is negative cosine x. And that's that. All over sine squared x. So let's split this up into two parts just for example's sake. All right, I have negative cosine x over one of these sine x's, and I'm going to multiply that to 1 over the other sine x. Okay, we know that negative is negative. Cosine x over sine x is cotangent x, and 1 over sine x is cosecant x. And there's nothing more I can do with that, so I'm done. So at the end of the day, we could say that the derivative of cosecant x is going to be negative cotangent x times cosecant x. And some professors or teachers might have it backwards. They might say negative cosecant x, cotangent x, but it's all good. It's all the same. But we did that using the quotient rule, and boy, was that fun. Use the quotient rule to derive the derivative of cotangent x. Well, what is cotangent x? Cotangent x is the reciprocal of tangent, right? And so since tangent is sine over cosine, cotangent is cosine over sine, like so. And if my job is to find out the derivative of that using the quotient rule, then I'm going to label the numerator u and I'm going to label the denominator v. Because the quotient rule states that if I take the derivative of u over v, I'm going to find u prime v minus v prime u all over v squared. So what is the derivative of each of these parts? Well, u prime is going to be the derivative of cosine, which is negative sine, like so. V prime is going to be the derivative of regular sine, which is regular cosine. V squared is going to be sine squared, so sine squared x, like that. So let's put it all together. The derivative of cotangent, that's a cosine, that was a close one, that was a close one. The derivative of cotangent x is going to be u prime v, so negative sine x, times v, which is regular sine x, minus v prime u, so minus cos x u, which is cosine, all over v squared, which is sine squared, x, like so. Excuse me. Now, negative sine times regular sine is negative sine squared x. Minus cosine times cosine is cos squared x, all over sine squared x. Now what I'm going to do is I'm going to factor out a negative 1 on the top. And I'm going to be left with sine squared x plus cos squared x. Now why in the blazes would I do that? Well, there's a Pythagorean identity that says that sine squared x plus cos squared x is just 1. So I get negative 1 times 1 up here over sine squared x. Negative 1 times 1, let me get out my calculator, is negative 1, so let's pull the negative out, and that leaves me with negative 1 over sine squared x. And if 1 over sine is cosecant, then 1 over sine squared is cosecant squared. So let me write that out. So when all is said and done, I know that looks a little bit sloppy, when all is said and done, the derivative of cotangent x is negative cosecant squared x. So not the prettiest looking thing in the world, certainly not, but the quotient rule gave it to us, and boy wasn't that a lot of fun. If f of x equals secant x minus cosecant x, then f prime of x is what? Well, this is just a matter of memorizing the derivatives of secant and cosecant. There's no attachments here, none at all. The derivative of secant is going to be secant x tangent x, so let's write that out. Secant x tan x minus the derivative of cosecant is negative cosecant x cotangent x, like so. And all we have to do here is just kind of simplify that double negative. So secant x, I like parentheses, it just looks prettier, tangent x minus a negative plus cosecant x cotangent x. And there's really not much more you can do. If you're going to try to be cute and factor and simplify, just don't worry about it. This is just a matter of memorizing cosecant and cosecant and secant and cosecant, and then just writing stuff out and doing the double negative, and we're done. Find dy dx at x equals pi when y equals secant x times ln of x. Ugh. All right, so this is not going to be pretty at all. In fact, I think this is actually not going to be so bad. This is what's going to happen. We're going to need the product rule for that guy right there. All right, so product rule, if you forget, is the ddx of u times v is going to be u prime v plus v prime u. So what I need to do is figure out what u prime is, right? U prime is the derivative of secant. The derivative of secant is secant x times tangent x, right? V prime is going to be the derivative of ln of x, which is just 1 over x. So coming back over here, right, we can now kind of put things together. dy dx is going to equal u prime v, so secant x tangent x times, oh, did I do the v? No, times v, so times ln of x, not pretty, plus v prime, which is 1 over x, times u, which is secant x. Okay, so dy dx is going to equal that. So let me actually erase that. I don't really need to simplify anything. There's nothing in here that needs to be simplified. There's nothing we can do. It's just now what we have to do is plug in pi. So if I plug in pi, I end up with secant pi tangent pi ln pi plus 1 over pi secant pi. So pi's everywhere. It's like Thanksgiving. All right, so hopefully we remember this stuff. Secant of pi is -1. Okay, and of course that comes from the fact that you have 1 over cosine pi. So secant pi is -1. Tangent pi is nothing. So I don't really care what ln of pi is because it's just going to disappear anyway. Plus 1 over pi. Secant pi again is -1. So you completely cancel out, and 1 over pi times -1 is -1 over pi. So that's going to be my guy right there. So we used product rule to figure out this stuff. We plugged in pi a bunch of times. We really only needed it once. And yeah, that's our answer. Fun stuff. What is the derivative of f of x equals sine squared x over cos x with respect to x? So this is what I'm going to do. I'm going to split this up. I'm going to split this up and make this sine x over cos x times sine x, right? Sine x over cos x is tangent, and sine is just sine. So now what I'm going to do is I'm going to view this as product rule. I'll call you u and I'll call you v and remind myself that d dx of u times v is u prime v plus v prime u. Right? The derivative of u is the derivative of tangent, which is secant squared x. Memorize that. V prime is going to be the derivative of sine, which is going to be regular old cosine, no negatives. So now this is just a matter of me putting together the product rule. U prime v is secant squared x times v, which is sine x plus v prime u, which is going to be cos x times tangent. Now, knowing what I know, let's simplify these a little bit and see if anything magical happens. It's possible. I'm not sure, but let's just have some fun with it. Secant squared x is 1 over cos squared x, okay, times sine x, plus regular cosine x, oh boy, that looks terrible, cosine x times sine over cosine x. These guys cross out. Okay, nothing special happens here, except if you want to, you can say that 1 sine over cosine is going to be tangent. And since that leaves you with 1 cosine on the bottom left over, we can call you secant. Okay, plus sine. And after all of that, that's basically all I can do. There's not much more I can do after that. I mean, nothing simplifies. I mean, there's no use in factoring any signs out because that would just turn you, I don't know, we're done. So after all of that, tan x, secant x plus sine x is going to be the derivative of that guy right there. Nifty, nifty, nifty. Find dy dx at x equals pi over 4 when y equals 3 sine x cos x plus 2 tan x. Ugh. All right, so this is what I'm looking at. Okay, u, our product rule. So u would be my u, 3 sine x would be my u, and cos x would be my v. You're just regular old, trig identity stuff that I don't have to lose any sleep over, so I'm not going to worry about you. Let me remind myself that the product rule is the d dx of u times v is u prime v plus v prime u. So, when I do this guy, if I called u 3 sine x, then u prime is going to be 3 cos x. V prime is going to be the derivative of cosine, which is negative sine x. So y prime is going to start out by me doing u prime v, so 3 cos x, v, which is cos x again, how nice, plus negative v prime, so negative sine x, u, which is 3 cos x. No, it's not. It's 3 sine x. Sorry, kind of snoozed there. That was a close one. Ooh, boy. Ooh, boy. And then plus 2 times the derivative of tangent is going to be 2 secant squared x. Now I have to plug in pi over 4. Okay, so let's clean this up just a little bit. This is what I don't want to do. What I don't want to do if I'm going to plug in pi is make these squares because it throws my brain off. I'm going to keep this as y prime equals 3 cosine x cosine x, because in pre-calculus I memorized these guys but with sine and cosine and tangent only. So I'm not going to go crazy trying to do secants and stuff like that. I can, but I won't. Minus 3 sine x sine x. And what I'm going to do is make this plus 2 over cos x cos x. All right? Y prime, when I plug in pi over 4, so y prime of pi over 4 is going to be 3 cos pi over 4 cos pi over 4 minus 3 sine pi over 4 sine pi over 4 plus 2 over cos pi over 4 cos pi over 4. Now, if you remember from the unit circle and stuff like that, cos pi over 4 is root 2 over 2. So you're going to be 3 times root 2 over 2 times root 2 over 2 minus, also, this is nice, sine of pi over 4 is also root 2 over 2 times root 2 over 2. Now, why is this good? Because you're thinking, oh man, I have to multiply all that. No, I don't. 3 times root 2 over 2 times root 2 over 2 minus 3 times root 2 over 2 minus times root 2 over 2 goes away because they're the same exact thing. And we're left over with 2 over root 2 over 2 times root 2 over 2. All right? So 2 over square root of 2 times the square root of 2 is going to be the square root of 4, which is 2, over 2 times 2, which is 4. So I get 2 divided by a half, which is the same thing as 2 times 2. And after all of that, you get 4. So isn't that lovely? It sure is. Kind of a weird, crazy problem, but yeah, that does it. And I believe that does it for Unit 2 for my videos. So I hope you're watching all of them and liking and subscribing. Please, I beg you.